Hi, my dear children. So today we shall see a video lecture on OMC and MC. What is OMC? Organometallic chemistry. And MC is metal carbonyls. Let's get started. So metal carbonyl compounds. So we all know what is organic chemistry and we know what are metallic compounds. But now we shall see how organo and metallic bonds have an importance. So as the name suggests, there is a direct bond between the metal and carbon. So this metal can be anything. It can be electropositive elements like first group and second group elements, and transition elements, and d block elements, etc. So basically the organometallic compounds of lithium and magnesium are very important reagents for preparation of some complex organic molecules. So that could be one of the applications. So these reagents make organic chemistry simple. So let us see the nomenclature. So here is one example: methyl lithium. So you can see a methyl group, which is an alkyl group, and lithium attached to it. So it is basically methyl lithium. And the same goes with tetraethyl, 4 ethyl groups with plumbum, that is lead. So tetraethyl lead. So you can expect a PG question. What is tetraethyl lead? Which is an anti-freezing agent or an anti-knocking agent, which helps in not freezing the fuel. Okay, so let us see the classification of organometallic compounds. As the name suggests, ionic organometallic compounds. So we all know that ionic bond is nothing but the transfer of electrons. So here the metal group gets the electrons from the anion of the organic compound. So here comes an example where C minus and A plus. Okay, so this is an electropositive element which belongs to first group, and you can see the second group element, calcium. So this C minus, the anion of the organic compound, gives electron to the electropositive element. So between this and this, you can expect a ionic organometallic compound. And next you can see sigma bonded. So sigma bond and pi bond comes in covalent compounds. So it is sharing, you all know. So basically it is a covalent bond between the carbon present in the organic compound and the metal present in the central atom. Okay, so this bond can be seen between weakly electropositive or non-metals or metals other than transition elements, like you have stannum, okay, or lead, and so on. So next comes pi bonded covalent OMC. So one best example which is important for PG also is ferrocin, which is a sandwich compound. So the pi electrons present in the cyclopentadienyl compound and the d orbital, the vacant d orbital of the metal atom, basically it is sharing between the pi electrons of the organic compound and the vacant d orbital of metal atom. So here the metal is iron. So this forms a pi bonded organometallic compound. And next is you see alkyl bridged OMC. The name itself suggests alkyl bridged. So it is two metals bridged by alkyl groups. So here comes an example: aluminium, where it is sharing an bridge bond between OMC. So when you are looking at the classification, we have come to a conclusion or a takeaway note that the MC bond character depends basically on the metal atom. Here what is changing is the metal. The metal character is deciding the metal and carbon bond. The carbon comes from the organic compound and the metal is from the central atom metal bond. Okay, so let us see metal carbonyls, which is a part of organometallic chemistry. So in your syllabus you will be having 5 compounds which you have to find out whether the compound is stable or not by using the 18 electron rule. So specifically let us discuss in detail about this 18 electron rule in this class. So but before 18 electron rule, just let us just see how these structures are taking place in metal carbonyls. For the first example, that is nickel tetracarbonyl, like the nomenclature just we discussed. So it is basically nickel will be the central atom, which is surrounded by 4 carbonyl compounds. So here you can see it is mononuclear, that is it just have only one nucleus, which is nickel here, surrounded by 4 carbonyl compounds. So C has maximum valency of 4. So this is how it is. So here the nickel is sharing with carbon, and the other 3 will be decided by oxygen. So this is how the structure is. So basically from metal carbonyls chapter, what is the outcome is you will be able to study the structures, and you will be able to study the stability by using its the 18 electron rule. So in this class we shall discuss a little bit of structures, and then we shall see 18 electron rule in detail. Okay, so basically metal carbonyls are classified into two, to be precise. One is mononuclear and another is polynuclear. So in this class we shall discuss dinuclear, trinuclear and tetranuclear. Okay, so in the first example that we've seen, it is nickel with the tetracarbonyl compound, which is into 2, to be precise. One is mononuclear and another is polynuclear. So in this class we shall discuss dinuclear, trinuclear and tetranuclear. Okay, so in the first example that we've seen, it is nickel with the tetracarbonyl compound, which belongs to mononuclear metal carbonyl, and the same goes with iron with the pentacarbonyl compound as well. So it is also mononuclear. Okay, so let us first check whether these 2 compounds are stable or not by using 18 electron rule. Just like we've studied in the coordination compounds, we've studied EN rule given by Sedgwick. So he suggested that if any metal compound can have or can obey the nearest inert gas configuration, then that compound can be stable. This is what his rule have suggested. So keeping this in mind, the same has been followed for organometallic compounds, specifically metal carbonyls. So let us see whether these compounds are stable or not, or whether they are obeying the 18 electron rule. Okay, so here electron count, the total electron count, that is the total number of electrons present in the metal plus number of bonds, that is if it is nickel tetra, that will be 4, so N will be 4 into 2 into electrons given by the terminal carbonyl group. So the terminal carbonyl group contributes 2 electrons, it donates 2 electrons to the metal. So this is what the formula is, just like EN rule. So let us see this formula works for nickel tetracarbonyl. Okay, so for the first example, how many electrons are present in nickel? So the atomic number of nickel is 28. So total number of electrons present is 4s2 3d8. So the total number of electrons present in the valence shell are 2 plus 8, 10, plus N is 4 in this case, into 2 electrons. So it is 10 plus 8, so it is 18. in total. So yes, so this nickel tetracarbonyl compound does obey 18 electron rule. Let us find out with the second example, pentacarbonyl iron. So iron, as we all know, it is the atomic number is 26. So the electronic configuration is argon core 4s2 3d6. So it is 2 plus 6 8, okay, plus 5 into 2, so 8 plus 10. So yes, it does obey 18 electron rule. Okay, so these two belongs to mononuclear metal carbonyls, and they do obey 18 electron rule. So let's take one more example, which is dinuclear. Okay, by looking all these structures have been studied by excellent spectroscopic methods such as X-ray or infrared. Based on those studies, it was suggested that it is not mononuclear, it is dinuclear in this case. So let us see this example now. So we have dinuclear metal carbonyl here. So let us see how many metal bonds are there, and how many terminal carbonyl molecules are there, and how many bridging are there. So as I told you, from IR frequencies and X-ray diffraction studies, it has been studied that there is back bonding taking place between metal and the carbon present in the metal carbonyl. Let us see the stability by using the 18 electron rule first. So as you can see, there is one metal bond. So keeping this in mind, one metal bond is there that we have to consider in the total electron count. And next we have three terminal attached to one iron and 3 terminal attached to the other iron. So in total we have 6 terminal bonds. And next we have 3 bridging electrons. So from this we can understand that iron belongs to 3D elements, so transition elements. So as we all already know that it has 8 electrons in total, and this 8 electrons plus 1 metal bond, 1 electron pair that we can see, and we have 6 terminal and 3 bridged. So 8 plus 1 9, 9 plus 9 is 18. So yeah, this dinuclear metal carbonyl compound also obeys 18 electron rule. So today's homework is tell me whether this is mononuclear or dinuclear or trinuclear or tetranuclear, and just tell me how many metal bonds are present, and does it obey an electron rule. So catch you in the next class, and I will give you the detailed answers to this in the next class. Thank you.